Hey guys, warm good evening to all of you. This is me, Tapash Kumar Pradhan, a student from the political science, and I would like to welcome to all of you to this session of my YouTube channel. So as you know, guys, we are continuation of the concept series of the ICT of paper 1 EGC political science. Yes guys, paper 1 EGC political science. So in this session we are going to discuss about the number system in ICT. Yes guys, you heard it correct. We are going to discuss about number system in ICT. So we will be discuss that how we can solve this number system if they gave in our examination. So for that we need a paper and pen. So you can't see me, so you can see the how we basically solve this problem. So without delay, let's get start. Okay guys, let's see how we can solve. So guys, so far so the number system is basically concerned in ICT. So there is a few of the value we need to be understand in basically the ICT number system. There is like binary. Okay, yes guys, there is a concept of like binary. So there is a decimal. Okay, decimal. There is a octal. There is a hexadecimal. Okay, so the value of the binary is like 2. That means like your 0 and 1. Yes guys, 0 and 1. Then for decimal, the value of the decimal is like 10. Yes guys, the value of decimal is like 10. Then octal, the decimal of octal value is like 8. Yes guys, you heard it correct, 8. Then hexadecimal, the value is like the 16. Yes guys, the value is like 16. But in our computer there is only 2 language is basically recognized by the computer, that 0 to 9. So 2 digit only. So that's why there is a concept of 10, 11, 12, 13. Computer is not recognize that thing. And for hexadecimal we use 0 to 9 with the A to E. Yes guys, we use the for hexadecimal 0 to 9 and A to E. And here A means 10, here B means 11, here C means 12, here D means 13, here E means 15. So this is how we basically understand hexadecimal. So this is how we basically understand hexadecimal. Again I am saying the hexadecimal value is like 16, but in our computer that understand only 0 to 9, and for hexadecimal remaining we use the A means 10, B means 11, C means 12, D means 13, E means 15. Yes guys, E means 15. So let's solve a problem in basically what they ask. So like guys, you can see here, if the binary equivalent of the decimal number 48 is this, and then binary equivalent decimal number of 51 is basically what? So guys, they ask the question like here, like if the number you are like basically the 48, okay, 48 decimal number is equivalent to the binary number of this 11. Okay, you can see double one basically 11 0000. So the decimal number of it is basically this is the binary numbers. This is how the binary numbers. And they ask the guys like if 51 is like a decimal number and you have to convert this number in the binary, what you need to do? So guys, there is a formula. So for that you have to understand that if they ask the question from decimal to binary to octal to decimal, you need to do what? You need to be divide the things. You need to be divide. Just remember this thing, that if they ask the question from decimal to binary, from decimal to octal, from decimal to hexadecimal, so guys, you need to do the divisible. Yes guys, from decimal to binary you need to be divisibles. But on other hand, if they ask the question from the binary, from the octal, from the hexadecimal, so guys, you need to do what? You need to do decimal. Then you have to remember you have to do multiplication. Yes guys, you have to do the multiplications. Yes guys, you have to need to do the multiplication from binary, octal, decimal, hexadecimal to decimal. to decimal, that you have to remember that you have to do multiplication. Just remember this thing I am doing with you, that how the basically you can do that things. For example, 51 a number in decimal, 51 a number in decimal, and you have to convert in binary. You have to convert in binary. So as I said, from decimal to binary you have to need to do divisible. Just divide the thing. 51 base value it's like 2, okay, 51, then you have to do the divisible like 2, okay. So 2 2 ja 4 ja, okay, then 1 is 11 ja, 2 5 ja 10 ja. So you have to write down the remainder here. Yes guys, you have to write down the remainder here. So 2 2 ja 4 ja, and one thing is basically carry forward, and this is 11, and 2 5 ja 10 ja, and one thing is basically remainder. So you have to write down remainder here. Then again 2 1 ja 2 ja, 2 2 ja 4 ja, and the one thing is remainder, so remainder you have to write down here. Then 2 6 ja 12 ja, so 0, like 0 is remainder, you have to write down 0 here. Then 2 3 ja 6 ja, 0 is real remainders, okay. Similarly 2 2 1 ja 2 ja, then basically 1 is remainder here. 2 1 ja 1 2 ja, then 1 is remainder here. Just write down these things, just write down this thing, and this is going to be your basically the binary numbers. So 1 1 0 0 1 1. So this is going to be your binary numbers. So let's check how basically it is, Yes guys, our answer is correct. You can also see here like the 50 51 51's number into the equivalent to binary is like our answer is like A, that means 1 1 00 and 1 1. Yes guys, 1 1 0 1 1. So okay, this is how the things. For example, if they ask the questions, then convert this thing into decimal. So as you know that I said to you that binary to decimal you need to do what? You need to multiplication. Binary to decimal you need to what? Multiplication. So this is binary, you need to do multiplication of it. You need to what? You need to do basically the decimal, you need to do decimal here. You have to remember that you have to do here the multiplication. Just like do that thing as I said, to the power 0, to the power 1, to the power 2, to the power 3, to the power 4, to the power 5. So just basically increase the base value from 0 to from 0 to, okay, just increasing the base value, from the right side. Yes guys, so here you can find that 2 root 0 is 1, so like 1 is here. Then this is how you have to multiplications, this thing also 2 0 is 1, okay, the 1, then 2 1 square like 2, 2, then 0. If you anything multiply with 0, then you can get 0. If you anything multiply 0, then you can get 0. So it is cancel. Then 2 4 ja, what is this? 2 4 ja is like 16. 2 4 ja is like 16. Then 2 5 ja is like 32. So 32. Just add these things. 30. Just take a base value of it. 30 for suppose this is 20, this is 10, 30. Okay. Then it here the 10, okay, then here 2 6 ja 8 ja 8 2 ja 10 ja, then 1 ja. So how many? This is how 51. So this is how the 51 is like our the value of the decimal. The binary number of this is equivalent to the basically the decimal number of the 51. So this is how the things. Again I am repeating, in computer there is number system. In this number system you have to understand that binary value to the computer, the binary value is 2, decimal value is 10, octal value is 8, hexadecimal is like 1 to 16. That is computer understand 0 9. For that we use the A to E, like A means 10, B means 11, C means 12, D means 13, E means 15. Yes guys, yes means E means 15, and we solve accordingly. That you have to remember two things, that from decimal to binary, octal, hexadecimal, you have to divide. You have to remember rule 1. This is how your rule 1. Okay. Yes guys, this is how your rule 1. But in your binary and octal and hexadecimal to decimal, you have to do multiplication. So this is how the thing, and we also did solving a problem with you, and you can also do the things, and if you have any doubt you can also share with us. So this is how a small effort from my side for this number system. I hope it is crystal clear you, and if you like my effort, do subscribe to press the bell icon, that you will not miss also end of the precious video. Thank you guys, have a nice day, and do share with your friend, because sharing is always caring. Sharing is always caring.